Hello everyone, welcome to the free lectures of the series Unit and Measurements. So today we will learn, this is the part 1 of the topics errors. Okay, in this part 1 we will learn types of errors and then the errors that are based on. Okay, in that based on we will learn uh, uh, errors that are based on observations and errors that are based on magnitude. Okay, in magnitude we have the absolute errors, relative errors and percentage errors, and based on observations we have the random errors, systematic errors. This we will get. Okay, so let's start. So now errors, right? So you see physics is all about experiments. Okay, so now physics is based on experiments, and to prove that experiments, okay, so now when we do experiments, new theories, okay, new laws and then new principles are developed, right? So now to prove that we need experiments, okay, and to prove in the experiments we need to measurements, right? We need measurements, right? And while measuring, okay, there often comes, okay, whatever values that we want, we don't get the exact one. Okay, some there might be a defect in the instruments, or there might be our negligence, so we do not get the desired values, right? So this uncertainty, okay, is called errors. Okay, when we do measurements, okay, at the times uncertainty happens, okay, the exact value we do not get, that uncertainty in the measurement is called the errors. Okay, so error means what? Errors means it is the uncertainty, it is the uncertainty in the measurement, measure MEACRMENT, okay, in the measurement of any physical quantity. Okay, any physical quantity is there. So when we are going to measure it, the uncertainty that comes will be called as errors. Okay, so now this error is based on, okay, is based on, it is classified in two ways. Okay, one is, okay, let's write it down properly. Okay, this error is classified in two ways. Okay, one is the based on observation, where we can observe the errors. Okay, the another one is based on magnitude, based on magnitude. Okay, based on magnitude means in number, this we will do calculations here. Okay, based on observation. Okay, observation. Okay, here we can observe the errors. Okay, so now the first one is the systematic error. Okay, so now its subtopic is systematic errors. Now in systematic errors, what happens? Okay, in systematic errors, the cause of the error are known to us. Okay, here we know what is the cause of the errors. Okay, cost of errors are, okay, known to us. We know what is the cause of the error. Okay, next one. So here again in subtopics we have in instrumental errors. Okay, in instrumental error we know what is the cause. Okay, that this will be capital letter A. Okay, so here we know what is the cause of the error. Okay, so in instrumental error, we know what is the cause of the error. Okay, when there is defect in the instruments, then that type of error is called instrumental errors. Now instrumental errors, we have the subtopics as this one, zero error. Okay, so zero error means what? We see that, okay, defect, it's a defect in instruments. Okay, instrumental error means defect, and what are the defect we will see here. So zero error means what happens in the instruments. Sometimes what happens, the initial reading is not zero. Okay, sometimes what happens, initial reading is not zero, and because of that the final result also we will not get the true value, right? So that type of error is called the zero errors. Okay, in zero error what happens, initial reading of the instrument is not zero. Okay, initial reading of the instrument is not zero. Okay, so this way it is known as zero error. The another one we have here, the least count error. So least count error. Okay, so least count error means, first we must understand what is least count. Okay, least count means it is the okay minimum. Okay, it is the minimum value that it can measures. Okay, and instruments can measures. Suppose the normal scales that we use, right? The normal scales that we used can measure only up to 0.1 centimeter, right? The scales that we used, right? The scales that we use can only measure 0.1 centimeter. Suppose this is our scale. Okay, suppose this one is 0 to 1. Okay, so here what will happen? 1, 2, 3, 4, 5, 6, 7, 8, 9, after that 10. Okay, so now what happens? Suppose this one is centimeter, and from here to here is 0.1, right? 0.1, 0.1. So these are all 0.1 centimeter. So if the length is up to here, right? Up to length is up to here, then we'll say 0.4 centimeter. But what happens if the length is here? So can we measure it now? No, this instrument cannot measure it, right? So this is called the least count errors. Okay, so after certain all instruments cannot measure less than its least count, right? So this types of error is called the least count errors. Okay, okay, this one is errors due to the least count of instruments. Okay, this error comes due to the least count of the instruments. Okay, so this is all about the systematic errors. Okay, now based on observations we have another one, that is, so here cause of the error is known to us. Okay, the another one is where cause of the error is not known to us. Okay, that one is called the random errors. Okay, random errors. So systematic errors, then we have another one, that is number B now. Okay, number B, that is random errors. Random errors. Cause of error are not known to us now. Okay, we do not know what is the cause of the errors. Okay, cause of the errors are not known to us. Okay, suppose when we are measuring the time period of a pendulums, you know pendulums, the bob is there, thread is here, and then this one is a pendulum, right? Now when we measure the time period of the pendulums, okay, when we measure the time periods of pendulums, what happens? Different time periods we get, right? Yes. Why we are getting different time periods? Is because regions, there are varieties of regions, like there might be wind speeds, air resistance. Okay, so the thread also might get elongated. So there are many regions which we do not know why we are getting the different values. So the cause of the errors are not known to us. This type of error is called random errors. Okay, so now we'll go to the next. Okay, so before that you can write the definition of least count. Okay, least count means, okay, this one you can write it. Least count means it is the minimum value an instrument can measure. Okay, minimum. How much instruments can measure? Our normal scale can measure only up to 0.1 centimeters. Vernier calipers can measure up to 0.01 centimeters. Okay, and screw gauge is also same like that. So this is the least count. Least count means minimum up to which quantity it can measure. Okay. So next we have, now we go to the based on magnitude. Okay, this one is finished. Based on magnitude. So based on magnitude, okay, so based on magnitude we have three types of errors are here, and remember we will calculate here. Okay, based on magnitude we'll try to find how many types of we'll try to find the magnitude, okay, quantity of errors. Okay, so based on magnitude we have three types, that is absolute error. We will learn it. Okay, now just you see the types. absolute errors. Next we have relative error. Okay, and then another one we have the percentage error. Okay, percentage error. Okay, let's understand it one by one. So number one, absolute error. Okay, absolute error. So what is this absolute error? Okay, it is a difference between the true value and measured value. It is a difference between the true value and measured value. Whatever you have measured, if it is not coming to exact value, then that difference is called the absolute errors. Okay, it is the difference. It is a difference between true value and measured value. Okay, so it is the difference between the absolute error. I can write it as true value minus measured value. Okay, and mode. Difference is always mode. Okay, positives. So now examples. Suppose gravitational acceleration due to gravity. What is this value? This value is 9 point. In CGS it is 980 centimeter second squares, right? Yes or no? Yes. Now when we try to find out with the help of an experiments, suppose we got the experimental value as 978 centimeter second square. Okay, this is the shortcut. Second square. So tell me what will be the absolute error? Yes, absolute error means what? True value minus experimental value or not? Yes. So true value is how much? 980. Experimental value 978. Right? Then how much we will get? Absolute error is how much? Absolute error how much we got? 2 centimeter second square we got. This is our absolute errors. Okay. Now next we have the relative errors. Okay, let's see what is this relative errors. Okay. So relative errors is nothing but it is the relative error. So relative error is nothing but it is the ratio of it is the ratio of absolute error to the true value. The ratio of what? Absolute error to the true value. Okay. So examples. What we got absolute error the times 2, right? Absolute error how much we got? 2 centimeter second squares. Yes or no? So now can you find relative error? So what is the relative error? Absolute error by what? True value or not? Absolute error is how much? 2. True value is how much? True value 9. G value is what? 980. Right? So 980. Then how much we will get? How much we will get? Cancel it. 1, 0, 9, 4. Right? 2 9 18. 2 4 1 9. Yes. 1 by 4 90. This is our relative errors. So relative error is how much? 1 by 4 90. Okay. You can make it. You can take it as the decimal, so you can convert it. Okay. Or you can leave it as it is. Next we have the percentage errors. Okay. So relative error how much we got? 9 1 by 490. Now we have the percentage errors. Okay, that is percentage error. Percentage error means what? Relative error is expressed in percentage. Okay, relative error is expressed in percentage. You got again? Relative error is expressed in percentage. That means the relative errors, relative errors will be expressed in percentage. So now if questions tell us to find out percentage error, okay, then what will be this? Formula will be like this: relative error It is expressed in percentage. Percentage means what? Multiply by 100. Right? So this is the formula of percentage error. Relative error into 100. So now next the examples. How much we got? Relative error is equal to 1 by 490. Right? Relative error how much we got? 1 by 490. So 1 by 490. Okay. So find, okay, that one if percentage error, how you will find? Percentage error is equal to relative error into 100, right? So relative error how much we got? 490. 1 by 490 into 100. Now percent will come. Okay, so G 0 cancel. So how much you do? Divide it. Divide it 10 by 49%. Okay, if you divide it, then how much you will get? 49, 10 is there, 0 point, and then 49 2 ja. Okay, that means how much you will get? 49 2 ja 98, right? 2 will come. Okay, so a 0.2% errors. Okay, so this is how we find the errors. Okay, absolute errors, relative errors, and percentage errors. Okay, so now here, see here. Okay, all of you see here. Now in this case, true value is given. Okay, but what happens? Most of the times true values will be not provided. Okay, thus they will give us number of observation, and then they will tell us to find the absolute error, relative errors, and then percentage errors. So here they will not give us a true value. Here we got the true value already. G is equal to 980 centimeter second squares. Right? After that we found the relative errors, and after that percentage error, everything we found. But if true value is not given, then what you will do? But there is n number of observation. N number of observation means we have done multiple times observation. So at the times what you have to do? Okay, first you have to take out their mean. Okay, then n observation, whatever value you are getting, suppose time period you are getting multiple time periods. Now out of that multiple time periods, they are telling us to find out the absolute error, relative error, and percentage errors. Now there is no true value. Measurement is there with us, right? Time period, the time period is there. The time period is the measurement. Okay, it is with us, but true value is not there. So you will find their mean, and that mean will be the true value. Okay, so let's do after that. Let's do after that. You will understand more better. Okay, so let's do that one questions. Okay, so before that you write it here. Note. Okay, that one only. We write it. Note. Okay, note if true value is not given. Okay, if true value is not given. If true value is not given, but an observation is there. Okay, but an observation is there. So now what you will do? Take. So for this n observation, you take it. Take, okay, mean as their true value. You have to take their mean as a true value. Okay. After that, calculate an individual absolute error. Individual absolute error, and calculate with that and okay, and okay, right, and with that individual and with that individual absolute error, calculate mean absolute error. Okay, mean absolute error you can find after, if you find mean absolute error, and after that then you can find mean relative error also you can find, and then mean percentage error also you can find. Okay, calculate mean absolute error, mean relative error, and mean percentage error you can find. So you write it down. If true value is not given, but n number of observation is there, then that, okay, there mean will be the true value. After finding the true value, each value you find the their individual absolute error, and through that individual absolute error you find the mean absolute errors. And then when you find the mean absolute errors, then you can easily find the relative mean relative absolute mean relative errors and mean percentage errors you can find. So write it down. So let's do one questions. Okay, the types of questions, and then we will end our class. Okay, in part 2 I will teach how errors are getting propagated. Okay, when you do addition, subtractions, the times errors is getting propagated or not. Yes, so that one we will learn in part 2. Okay, suppose, okay, example, okay, the time period of a pendulum are found to be 1.2 seconds, 1.3 seconds, okay, 1.2 second again, 1.3 second again. Okay, so now four observation, now n number of 4 observation here. For questions telling us find, okay, so questions telling us find number 1, number A, mean absolute error, number B, okay, mean relative error, and number C, mean percentage error. So how you will find here? Is there any true value here, so that we can minus the measured value? This is our measured value, but is there any true value? True value is not given, so that means we have to find it, right? So let's solve. Okay, let's solve. Solve means let's first say the time. Okay, let us denote with t1. T1 is equal to how much? 1.2 second. Then t2 is equal to how much? 1.3 second. t3 is equal to how much? 1.2 second. And then t4 is equal to how much? We have 1.3 seconds, right? So this is our values. Now we have to find the mean absolute error, relative error, and percentage errors. Okay, let's find it out now. So now true value is not provided, so we have to find that true value. What is true value? True value is the mean. Their mean is a true value, right? So mean, okay, or true value. Mean is our true value. Okay, so how can we find the mean? Mean formula is what? Total observation, total observation, and then number of observation. This one we know. Okay, this one we have done in our lower class. The total observation is how much? 1.2 plus 1.3 plus 1. Okay, 1.2 plus 1.3. How many number of observation is there? There is 4 observation, right? 1, 2, 3, 4. So 4 observation is there. So now what will be this? 3, 4, 5, 5, 3, 8, 10, right? 0. Okay, 1 is there. 1, 2, 3, 4, 1, 5. So 5 by 4 we got. Okay, so you find it out now. Okay, so how much will get? This one will be 1 point, right? So now 1.10. So it will be what? How much? 4 divided 5, right? 1, 4, 1, 0.4 to the 8, 2, 1 point. So let's leave it up to 1.2 only. Okay, 1.2, because here you have only 1, 2 significant here, right? 2 only. Okay, 1.2. So this is our mean. This is our true value. Okay, 1.2 second. So now can you find the individual absolute errors? What is absolute errors? True value minus measured value, right? True value how much we got? 1.2. Measured value is, this is our measured value. So now, okay, so let's, okay, there's delta t1. This is the let individual absolute error. Okay, del t1. Del means very small. Okay, del t1. So true value. Okay, true value minus measured value, right? And mod. So true value is how much? True value is how much? True value is 1.2, right? Minus measured value is how much? Measured value is also 1.2. That means how much we got? 0. Here no error is there, right? Next we have del t2. So del t2 will be how much? 1.3 minus how much? True value 1.2. This is true value, right? Yes, 1.2 minus 1.3. So it will be 0.1, right? Similarly, you can find it out for del T3. Del T3 will be how much? 1.2. So it will be 0. And similarly, how much you will get for del T4? Del T4 will be how much? 1.3 is there. So 1.2. That means 0.1. We will get this one, right? So del T1 how much we got? 0. Del T2 how much we got? Del T2 0.1, 0.1, del T3 0, and del T4 0.1. Okay. So now this one is the individual absolute errors. Now we have to find the mean absolute errors. Okay, we have to find what? Mean absolute errors. This is our true value. Okay. So now we have to find the mean absolute errors. Number A. Okay. So mean absolute error. So mean absolute error means what? Total number of errors del T1 plus del T2 plus del T3 plus del T4, and the observation is there 4. So that means what will be this? Del T1 how much we got? 0 plus del T2 0.1 plus del T3 0 plus del T4 how much we got? 0.1 divided by 4. That means 0.2 divided by 4. So how much you will get this one? How much will get? How much will get? Mean absolute error how much will get? Okay, let's wrap with this one. Okay, so how much will get mean absolute error? So mean absolute error how much we got? 0.2. That means it will be what? It will be 2 by 40 or not? Yes or no? Yes. Okay, you can cancel it, right? Okay, so 2 1 the 2, 2 to the 4. So 0.1 by 2. So how much you will get? 0.05 you will get, right? 0.05 you will get. Yes or no? Yes. Or you will leave it like this only. Okay, 1 by how much? It will be 20. Okay, this point will come this side, decimal will come this side, then will be 1 by 20. Okay, next number B, what we have? We have to find the relative error, mean relative error, mean relative error. So what is the formula of relative error? Is the absolute error, yes or no, by true value. So what is the mean absolute error? Right? Mean relative error means mean absolute error by true value. So mean absolute error how much we got? 1 by 20. And true value is how much? True value was how much? True value was 1.2, right? Yes or no? 1.2 or not? Yes, it was 1.2. Okay, 1.2 second it was, yes. Okay, so what will be this? So 1 by 20. Okay, so 1 by 20, that means 1.2 means 12 by 10. So that means what will be this? 1 by 20 into 12 by 10, right? Yes, this will be like this only. Oh no, no, you will get reverse. You will get 10 will go up, 20 will come down. Okay, 12. So what will be this? How much will get? 1 by 24. Okay, this is our mean relative errors. You can make it decimals. Okay, 1 by 24. Now what if they give us to find out the mean percentage errors? The mean percentage error formula is what? Percentage error formula. Percentage error is just relative error is expressed in percent, right? So percentage error is what? Formula. Percentage error is equal to what? So this one is mean percentage error we have added. So mean percentage error, right? So mean relative error into 100%. Okay. So mean relative errors. How much we got? 1 by 24 into 100%. So can you find it out now? Can you find it out now? So 24 into 100, right? 24 4 ja. 24 4 ja. 24 4 ja 16. Right? 196. Right? So 26 4. Okay. So what will be this? 140. So 24 into 6. No. 5 only, right? 5 percent, but then 11 12. Okay. 0.5. So how much will be? 5 for the 20, 10, 11, 12. So this much we will get. So that means 4.5%. So what is the percentage errors? The percentage error is 4.5%. Okay. So this is how we found the percentage errors, absolute errors, and relative errors when there is n number of observation is given. Okay. So examples. I'll give you one examples. You can do it. Okay, as a homework. Okay. So question is that. Okay. So question number 1. Okay, some time period of pendulums are noted as okay, the time period of pendulum are noted as number A. Okay, as T1 is equal to 1.24 seconds, 1.24 seconds. T2 is equal to 1.23 seconds. T3 is equal to 1.41 second. Okay, so and T4 is equal to 1.4. This one is 4.84. Okay, 1.21. So 1.23 second. So up to here only you do. Okay, and then okay, T5 is equal to 1.23 second. So find number A, absolute errors. Number B, relative errors. Okay, and then number C, all mean. Okay, all mean, and then mean percentage errors. Also you find it out. Okay, this is a questions. It will be homework for you. Okay, so the next that is left in the errors will cover in the part 2. So thank you and keep on studying.